Good morning. Let us demonstrate that the velocity in the wake is twice the induced velocity at the level of the rotor, that is, W equals 2 times induced velocity. For this, consider the following thing. Consider that we have the disk and the air is coming from up and is going to contract down. Consider now one area up in the blade, 1, for example. This is the area of the disk, and consider down in the wake another area, 2. Consider also that up in the wake the velocity will be, of course, V of the air, V, and the pressure, P0. Of course, when we are in hover, this is 0. At the level of the rotor, we will have up on the rotor pressure P, down under the rotor pressure will be different, P prime. The velocity at the level of the rotor will be V plus VI. Assume that now down in the wake velocity will be V plus W. What are the pressures? Now, for the drawing, we say the pressure on the rotor is up in the air we have a pressure P0. At the level of the rotor we have a pressure P. So we have a decreasing in pressure, and under the rotor we have a higher pressure P prime. And then of course we have again P0 down in the wake, so the pressure is going again down. So this is P0. Now, what are the velocities? The velocity distributions between the higher and the lower area are up in the wake the velocity will be V of the air. At the level of the rotor we have the velocity of the air V plus the induced velocity VI, so the velocity is increasing, and then further down we have the velocity V, and we will have a velocity W, which we assume that is increasing. So the velocity is just increasing. Now, this is a picture, and now we are going to see what are the laws that we can write in this area in actuator disk theory. For this, we need first the conservation of mass. Conservation of mass. You know that the mass flow rate through the rotor, it is constant and on every section, and it is also at the level of the rotor, it is rho p r square, the area of the disk, and then the velocity at the level of the rotor, v plus vi. We know also that the momentum is conserved. Conservation of momentum. Namely, we know that the thrust equals with the change in momentum. Momentum down minus momentum up. So, substituting the momentum value, T is m dot v plus W down in the wake minus m dot V. So it means that the thrust equals with m dot W equals with, if we substitute this formula, it is rho p r square V plus VI multiplied with W. So this is the thrust in the actuator disk theory. Now, let's go further. And then, try to write the Bernoulli relations between the up in the rotor, the disk rotor, and down in the rotor. Between section 1 and section D, we have the Bernoulli P0 plus rho over 2 V squared equals with P plus rho over 2 V plus VI square. So the static and the dynamic pressure. Then, between the disk and the second section, so down in the rotor, we have down in the rotor P0 plus rho over 2 V plus W squared equals with P prime plus rho over 2 V plus VI square. Now we are going to subtract these two equations. It will follow that rho over 2 V plus W squared minus rho over 2 V squared equals with P prime minus P. But you remember that we just demonstrated that thrust equals with the change in momentum equals with m dot W, so it was rho P r squared V plus VI. But we also know that the thrust is a change in pressure, so equals with P r square multiplied P prime minus P, so it equals with P r square, and if we substitute this answer into here, it is rho over 2 V plus W square minus rho over 2 V square. So this is rho over 2 P r squared twice VW plus W squared. Now we are going to equalize these two relations as they mean the same, thrust. So we will obtain that V plus VI multiplied with W equals with 1 over 2 W times 2V plus W. Of course, we just neglected rho PR square. Now, in this equation, W, it goes, velocity, it goes with velocity, and you see already that velocity down in the wake equals with twice the induced velocity. So we have been demonstrated that the velocity down in the wake, it is twice the induced velocity at the level of the rotor, and that the wake is contracted. This ends the demonstration of today.